Hello, this is Systems of Linear Equations and Inequalities, Solving Linear Systems Algebraically, Example 4. There's an A part and a B part, and first we need to solve this system algebraically. It looks like you could multiply the first equation by -2 and then solve this by linear combination. Now the book solves this by substitution. I'm going to go ahead just for variety. I'm going to solve it by linear combination. I'll multiply the first equation by -2. So this becomes -2x. This becomes positive 4y. And 3 times -2 is -6. Okay, so now I can add these two equations, and the 2x and the -2x adds up to 0. The -4y and the positive 4y also add to 0. So on this side I get 0. And it's equals, and 7 plus a -6 is 1. So this is not true. It's actually, in mathematics, that's called a contradiction. So because we got a contradiction here, there's no solution. So for this equation there will be no solution, and let's see, I'm just taking a look at what the slope is here. These must be parallel lines. That's what it's got to be. So if you take a look at the slope here and just rearranging these things in my head, I think I get a slope of 2. See, the slope is 2 for both of these when you switch it into y equals mx plus b form. So, and when the slope is equal, that means they're parallel lines, of course, so that's going to have no solution. So here's another set of equations, system of equations we're expected to solve. Now this is Algebra 2, and you should have some experience with equations, and some things should jump out at you here. First of all, this is not an equation that you should solve just like this. All of these are divisible by 2. So the first equation, we could divide that by 2, and we'd end up with 3x minus 5y equals 6. See, that's a little simpler. And looking at this second equation, that's divisible. All of those are divisible by 5. So dividing by 5, we'd have -3x plus 5y equals -6. Okay. Now if we add these two equations together, we get 0 equals 0. So that means that they're the same line. And sure enough, look at, if you multiply either one of these equations by -1, you get the other equation. So these equations are really the same line. Here they made them look very much like different lines, but when we work on it a little bit, we can see that the equations really are the same line, and if you proceed and try to solve this, you end up with 0 equals 0. Now that's true. There's no problem with this. That means there's an infinite number of solutions. And so the big difference is that this is a special case, a weird scenario. It's two lines that are really the same line, but we get something that's true. That means it's an infinite number of solutions. And the last time when we tried to solve it, we got 0 equals 1, a contradiction, so that means there's no solution.